Hi, my name is Aditya Porwal. I'm an electrical and computer science student at the University of Calgary. Today, I'd like to discuss about a project that I did in my first semester here at UOC. In my first semester, I took a course named Machine Learning and Data Mining. The project was a requirement to finish that course, and the name of this project is Ocular Disease and Intelligent Cognition. This project was basically revolving around two tasks, gathering a data set or creating a data set and using that data set to predict the eye diseases using deep learning or machine learning techniques. Okay, so for my project, I used deep learning techniques, and I like to start with some facts about eyes and eye diseases. Sight is the most powerful or most important sense out of the five human senses. Everything we do in our day-to-day life is revolving around eye in one way or another. The moment we wake up, we start using our eyes, from brushing our teeth to turning off the light before we sleep. Everything requires us to use our sight. Thus, preserving our sight is important and is necessary. Our eye can suffer a number of diseases, which can be diabetes, diabetic retinopathy, myopia, glaucoma, cataract, and early detection of these diseases can save our sight. Detection of eye diseases through an ophthalmologist is very challenging and a long and time-consuming process. Even with the help of support systems such as computer-aided diagnostics, it is not feasible as the computers or the systems are very expensive. So, what is the solution to this problem? Here we thought of switching to a deep neural network-based diagnostics, where we train a deep neural network or deep learning model on the eye images with different classes and use the trained model to predict the outcomes. We don't need the domain-specific knowledge once the model is trained. And let's say I can just go to the clinic and ask the person over there to click the image of my eye, and the person can just fit the image to the deep neural network, and I'll get my diagnostic as soon as in a jiffy, in a jiffy. Yeah. Okay, so this is very inexpensive and a quick technique because it just requires the image of our eye, and that's it. Okay, so the dataset that we used for this was available on Kaggle and was provided by Shandong Medical Technology. It had images of eyes from about 5,000 patients. 7,000 images with labels were given there for training of a model, 1,000 image for testing the model. It had eight classes, normal, diabetes, glaucoma were three of the eight. The diagnostic keywords of each patient were also given. Along with the images, we had a CSV file, comma separated value file, which had a lot of information such as gender, age, weight of the patient, and much more. Uh, since an eye can suffer many diseases, this is a multi-class classification problem. And yeah, let me quickly switch over to my code so that I can explain it further. Okay, so this is the code that I wrote for this project. Here I'm importing all the necessary libraries which I require. TensorFlow for machine learning, NumPy for numerical calculations, Pandas, C1 for visualization and stuff. These are the global variables that I declared. And the image size is 224 by 224, the learning rate for the CNN model, learning rate for fine-tuning our model, all the classes in the dataset. Okay, so here are four randomly selected images from the dataset. Here we can see that our eyes are made up of thousands of many tiny little nerves, and we cannot see that the details of those nerves pop out. So to fix that, we use Clair image processing technique. Here, for example, this is a normal image, and we can say that it's blurry. And after Clair, the image is more sharpened, which was the case in our project as well. After Clair, this was the result of the images. Here we can see that the nerves are like popping out, the details are highlighted. And yeah, okay, from this pie chart, we can see that over 75% of our data set is made up of three classes only, which is normal, other, and diabetes, which creates another problem of imbalanced data set. Okay, and to fix that problem, we have two techniques, undersampling and oversampling. Undersampling is what we use in our project and is uh, basically the technique where we take few samples from the majority class, which is the blue colored class here, and reduce it to the size of minority class. While oversampling is a technique in which we repeat the minority class to the size of majority class. Switching back to the code, here this is the age distribution of all the patients. Most of them were in their mid-50s. The patient sex distribution, gender distribution. Okay, moving further. This is the place where we do the undersampling. We are selecting four classes, cataract, normal, glaucoma, and myopia. And we are taking 300 images from each class. So out of, let's say, we had around 2,000 images for normal, other, and diabetes. We took only 300, and that's basically undersampling. Okay, here we can see that our new data set is much more balanced. It's a better data set. Now we have four classes: normal, cataract, glaucoma, and myopia, which are very equally distributed. This is the Clare part that I talked about earlier. Now we split our data set into three parts: train, validation, split. Okay, so here we can see we have 1,347 images for training, 673 for validation, and 225 for testing. Okay, so this 1,347 images for training creates another problem of having a small data set. We know that our deep neural networks require huge amount of data to train themselves and predict some valuable outcomes. But with just 1,347 images, creating a deep neural network from scratch doesn't make sense at all. So to solve this challenge, we surfed on the internet and we found a solution. There's a technique called transfer learning in which we use a pre-trained model to predict the outcome on our given data set. So this happens like we take the pre-trained model, freeze the output layers which predict the values, and train the remaining rest of the layers on our data set to generalize on our data set. And then we unfreeze the output layers to make the predictions. Also, our target value is categorical, so we have to switch it to numerical, we have to change it to numerical, and this is how we do it using one hot encoding. We also did data augmentation to fix the problem of small data set. We generated random images, like images with a minor rotation, which can be seen in the second image, and we flip the images left to right, horizontal. So this is my CNN model, which I just did to test it if it's worth it or not, which was definitely not the case. This is the VGG model, the inception model, and the exception model. Okay, so yeah, we use callbacks to stop training our model if the validation loss increases. That is to stop overfitting the model. And these are the graph of the best model. This is from exception, the training of exception. Here we can see that the accuracy is increasing and the loss is decreasing, which is a good thing. And that's the prediction from exception. Out of 225 test images, 177 were predicted right. And this is a single class classification, which we did. And I think this is a good result given our small data set. So yeah, this is like the project in a nutshell. And I'm like really happy that I did this project because I think that this can help revolutionize the industry completely. Yeah, okay. That's it. Thank you.